Okay, so on this graph, which I asked you to graph, you recognize there should be 3 zeros because there's a third degree polynomial, but you only see 1. Where are the other 2?
Imaginary?
They're imaginary. We can't see them on our graph because they are imaginary.
Wow.
Well, how do I find them?
Oh, so first we have 3.
Well, what's the one that we see?
3.
The 3.
That's what I thought. I was like, at first, I was like, bro, I thought somebody's name just got referred.
No, I swear.
Someone dropped the 1.
On and on.
So if this works, what should I get?
A 0.
A 0.
4 times 3? 12.
So is 3 a root?
Yeah.
Is 3 a 0?
Yes.
Is 3 a solution?
Yes.
Notice how they're all interchangeable there? You okay with that one?
That's right.
Then you said the others are imaginary, so what do I do? I can do the quadratic formula. Isn't this x squared plus 0x plus 4?
Yes.
But because the b term is a 0, I don't have to worry about it. So what I really have is x squared plus 4 equals 0. Okay with that?
Yep.
Can I solve that without the quadratic formula?
Yeah.
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 What can I do?
X minus 4. And then you take the square root. You must probably take the other one.
Square root
I love candles so much.
x equals. What does x equal?
It will equal I
Because I took a square root
2I.
plus or minus. Because I took the square root of a negative, it's going to be imaginary, and the square root of 4 is 2i. So what are my 3 solutions?
Plus 2I minus 2I.
So I've got 2i and minus 2i. What was the other one?
3.
Is that much harder than what we did on Browser?
Yeah.
What makes it that much harder?
How's the I?
The eyes make it a little bit harder. That is a fair statement.
If there's no 0, you have to plug in.
What do you mean?
Like, you know how there was a 0?
Well, we can't quadratic with a cubic.
Oh! Yeah. Oh.
So we kind of have to find something to start with and narrow it down. Does that make sense? Our objective is to get it down to a quadratic and then find the rest. So we're kind of taking our reals and our rationals and our nice pretty numbers, take those out, take those out, take those out, and get down to the end, and then quadratic, find what's missing. Make sense? There's another one. I spiced it up a little bit here. But you're still graphing. What does graphing it first help me to do?
Find the zeros.
It's going to find me the nice, pretty, neat, easy zeros, right? Because what happens when I start picking those off? The more of those I get rid of, the easier my problem gets. It's very, very true. There's only one. So that means I've got 2 imaginary ones, right? Is the one that I have a nice, pretty, neat, clean one? No. Why do you know it's not a nice, pretty, neat, clean one? Because it's in between 2 numbers. It's a fraction. I like this. So, what are my possible answers? Well, remember, I take the Constant term. Factors of the constant over factors of the coefficient. So I know 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 12 over 1 are not good for me, right?
Yeah.
Why? Because I have no nice pretty roots. So I'm looking for the fraction roots. 1 over 2, 2 over 2 is 1, 3 over 2, 4 over 2 is 2, 6 over 2 is 3, 12 over 2 is 6. So I'm looking at these two boys, right? So based off of my calculator there, which one of those is the one that I want to use? 1/2? Are you sure? Oh, you didn't look at your graph? You're looking at me. 3 over 2? We think possibly?
Yeah.
So we're thinking 3 over 2. So if I do 3 over 2 in the synthetic division, 2, -3, 8, -12, drop a 2. 3 over 2 times 2 is 3, 0, 0, 8. 3 over 2 times 8 is 12. That really hurt for some of you. A fraction, no. For those people, watch this. Notice how there's 4 terms there. What's the first set have in common? What does the second set have in common? They're both divisible by 4. So what happens? Notice how they have this factor. Wouldn't that be? You can still do factoring by grouping, even after the fact. Make sense? Just another option to show you that math works. It always works. It works together. It's magic. So what do I do with what's left? Well, isn't that 2x squared plus 8? How do I solve from there? Well, I can subtract 8.
Okay, first two were just numbers. Second two, solving for that.
So my answers are 3 over 2. And because remember, when I take it squared, I have to take into account it's positive and it's negative, right? Still somewhat comfortable? Let's try this one. So most of you go straight to your calculator, and that's fine. That's okay. Because I see a 4th degree, how many solutions do I expect? 4. If you don't have, if it's a 0, you don't have to put it. It's okay. It just be 0. No.
So this one is it all one? No, I mean,
All of this stuff is.
Now, I teach math for a living, so I know what to do when I see a problem like this. When I see this, what do I notice? Just everything up there has what? So I'm going to factor an x out first. Just because I know what one of them is. I know that x by itself equals 0. So I know that it crosses at 0. If you look at your graph, you should see, hey, it crosses at 0. So I have one. So if you look at your graph, do you see another nice, pretty neat one? 1, okay. So we said 1. So I got my 0. Now I'm saying 1. 1, -5, 3, 1. One worked. Still okay with me? How many more do I have? Do I see them on my graph?
Yes.
Are you sure?
Oh, yeah.
Only if they just.
If you have one, then it's like no.
There's something on there, right? But it's not a pretty one. Okay. This is where I use the quadratic formula. I see it, so it is a real number. Does that make sense? It is a real number. But it is not a rational number. Why do I know that?
Because it's,
Well, what are my rational factors of this? 1 and -1, right? The constant term 1 and -1. It is not 1 or -1. So what do I know? It is irrational. Because it is not one of its rational options, it must be irrational. So I'm going to do the quadratic formula with what I have left. Negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. Well, -4 squared is 16. -4 times -1 is +4. So 16 plus 4 is 20. So 4 plus or minus root 20 all over 2. Almost. I have to simplify the root 20 first. Can I factor down a 20? 4 times 5. 2 and 2. So doesn't 20 become 2 root 5? Hey, you guys did learn something once upon a time. Now I'm going to divide everything by 2. 4 divided by 2 is 2. 2 root 5 divided by 2 is root 5. So I've got 2 plus root 5 and 2 minus root 5. What were the other options that I had? So I had 0, 1, 2 plus root 5, and 2 minus root 5. What's something that we have noticed every time we have an imaginary number? What about when I have these irrational numbers? A square root. I'm always having what? They always come in pairs, right? They never exist alone. They always come in pairs. Which is where these theorems come from. This first one is the irrational root theorem. I'm going to sum this down for you so you don't have to write that whole thing, because that whole thing is really hard to read and it doesn't make a whole lot of sense. This says if a polynomial p of x has rational coefficients and a plus b times the root c is the root of the equation, p of x equals 0, where a and b are rational and the square root of c is irrational, then a minus b root c is also a root for p of x equals 0. That hurts my brain to understand, so I know it hurts your brain. What I'm going to sum that down to, for every root, you hear that? For every root, you must have its opposite. So if I had, for example, the square root of 5. What must I have with it? Negative square root of 5. If I had 6 plus 7 square root of 2, I have to have the negative version too. Does that make sense? And that's coming next. Every time I have a square root, I have to have its conjugate opposite. Does that make sense? And Tobias got ahead of me and said, hey, you have to have that for i's too. That's exactly right. That's called the complex conjugate root theorem. For every I, you must have its opposite. So if I have 2i, I must also automatically account for what? They cannot exist alone. You understand that, right?
Can't you put plus if you're solving it? Because I don't think HRW will let you do it, but like if on the test, can't you put plus or minus 2i?
You can, but what we're about to do, you cannot. And I'm going to show you, you'll understand when you see it. Oh, that's why I have to do them both separate. So what if I had 3 minus 4i?
3 plus 4.
I have to have 3 plus 4i. Because remember, the square roots and the imaginaries come in pairs. They cannot exist alone. Make sense? So what if I had this problem that had 7i and root 3? So I'm also going to have what? Negative 7i and negative root 3. Because they cannot exist alone. They must have their partner. Make sense? Even if I had, for example, 3i and 5i. Well, they're 2 i's, they're already together. But what do I also have to have? Negative 3i and negative 5i. They must exist with their partner. Think you got it? Now, here, I'm giving you the answers. And I want you to give me an equation. Huh? I'm telling you the roots are 0, root 5, and 2. I want you to write an equation. What's the degree of the equation?
X cubed.
Well, you almost learned something.
X and squared. A fourth.
Why to the fourth?
Because you have a square root.
Because I have a square root, I have to add in what? The negative square root of 5. Very good. So anytime you get a square root or an imaginary, you have to pick up its partner. Does that make sense?
Yes.
Now, these are solutions, yes?
Yeah.
Our task is to rewrite this as factors. What happens when I have a 0?
Oh, there's no number at the end.
So that's just what?
Placeholder.
X plus 0, right? So X. What about 2? Because I have a solution of 2, what's its factor?
4.
4?
No.
2?
No.
1.
No.
8?
Oh.
Because aren't I claiming that X equals 2? Subtract 2, subtract 2. So that's what I put in as my factor. Make sense? Now that you've seen it one time? You remembered that, you just, for whatever reason, didn't remember that. So what do I do about the root 5s? So it's going to be X plus root 5 and
Minus root 5.
make sense now somewhat? Now, what do I do next?
Do the thing.
I got to do the
Distribute
thing.
it.
So it's telling me to multiply, so I'm going to do some distribution, right? Now, word of advice. The best place for you to start is at the worst stuff.
So the square root of 5.
So I'm going to do the square root of 5s. Now, I've been around the block a time or two. I know a thing because I've seen a thing or two. So I am going to FOIL that first. There's a reason, and you'll see it as we do it. X times X. X times negative root 5. Root 5 times negative root 5. What is root 5 times root 5? Wouldn't that be root 25? What is the square root of 25?
5.
So when you multiply two roots, don't they cancel? What happened to those two terms in the middle? That's why we took care of the nasty stuff first, because they are conjugates. They clean up really nice. What would I do next?
Distribute.
Okay, so he's saying distribute the X. I'm gonna one up you. I'm gonna go ahead and FOIL the nasty stuff first, because I like to take the worst stuff out of the way and then start distributing. Does that make sense? So what I'm gonna do is FOIL that next set of parentheses there. X times X cubed, or X times X squared is X cubed. Negative 5X minus 2X squared plus 10. Now I can distribute that X, but I want to kind of two-step here just because I like these to be in perfect order and they're not. So as I distribute, I'm going to reorder. Is that going to hurt your brain if I do it two steps at once? X to the fourth minus 2X cubed minus 5X squared plus 10X.
Why does this skill involve like every single thing we've learned this year? It's like quadratic formula.
Because this is algebra 2.
Factoring, freaking.
Remember how I told y'all everything we learned is not going to go away, and y'all go, oh yeah, whatever, and then here we are. I'm not crazy. Some people get like, I've never seen this before in my life. I'm like, well, you haven't, doesn't mean I've done it. What's the difference? First period? Some of them, yeah.
Especially with the non-exam assignments.
Yeah, that's a lot. I haven't counted in a while.
At the beginning of the year, it was like what, 30, 40 something.
Don't even want to think about what it is now.
Probably in the hundreds.
Probably.
I know that.
Yes. What do you think? Think you can do this? All right, I'm gonna give you one here. I'm giving you 4i, 2, and negative 2.
So there is 4 solutions.
So there's 4 solutions, so it's 4 degrees. So because I see 4i, there must also be
Negative 4.
negative 4i, okay. The next step would be to write the factors, yes?
Yeah.
What would the factors look
It's
like?
easier to do it than the I.
X minus 2.
Let's get it, Kayla.
Now all I gotta do is multiply, right?
So you do the nasty ones first.
Do the nasty one first, yes.
So you do X. You're 4 then, right?
Do you believe it that someone said, what's FOIL mean?
Oh, really?
Yeah.
Me?
What?
When?
Nuh-uh.
Today.
Casey, was it Casey?
No, it wasn't Casey. Casey didn't say anything. I said good morning, Casey, and she didn't do it. And then I turned my back and she smiled and I saw. She loves me on the inside.
Can you do 4IX?
If you're multiplying that, must be
Definitely not.
negative 4ix or something.
Yeah.
What's 4 times 4?
What?
That one.
Okay. What's that times out?
Negative 1. Well, I squared is
Okay,
negative
okay,
1,
I
right?
like it, I like it.
Yeah, I still don't get it.
All right. So x times x, x squared. Outside, x times negative 4i. And then the inside, what's going to happen to those terms? They're going to cancel out because they're the conjugates, the middles cancel. So I can go straight to the last, right?
69.
So it's negative 16i squared. Well, you told me I squared is,
-1.
so wouldn't that change the sign?
Wow.
Who would have guessed it?
That's why I always tell you take care of the nasty parts first, because what's going to happen,
Not
hopefully,
always nasty.
it's going to clean up and it's going to look better.
And then it's
And
gonna
those
be your friends.
they cancel out too, right?
Why do you think they're going to cancel out too, Andrea?
Because it's negative.
Because it looks just like this, only there's no I. So I anticipate, hey, there should be some stuff that cancels there too. So it's going to be negative 2x, positive 2x. The middles cancel.
So if
Okay.
they're like that, you just go to the first one and the last one.
Yes, you can, because the middles will cancel. So what do I do to this last piece?
X to the
Combine my like terms.
Wow. Who would have guessed it?
What do you think? Pretty cool. Let's try another one. Like this one.
multiplicity.
Multiplicity. There's a new word.
Hey,
It's not really
I've
a new
heard that
word.
before.
We talked about multiplicity. What does that mean?
I think you're multiple.
That means it's multiple. You're not. You're in the right ballpark, yeah. So what's the factor of this one here? Remember, I'm taking the opposite. So x plus 1. What does the multiplicity of 3 mean? That means it's used 3 times, right?
Yeah.
That's why we cube it. Oh, man. And what about the 3i? The x minus 3i? But I also have to have x plus 3i. Oh, man.
Oh man, oh man.
Now, remember a few minutes ago when Holden said, dude, this is like everything we've ever learned?
That's all algebra 2 is. It's compound math.
It's like everything we've ever learned. I'm going to start here with the nasty part because that's kind of what I've trained your brain to do. If I FOIL out the imaginary complex conjugates, what's going to happen?
They're gonna cancel out, so it's x squared
So it's x squared. The middle terms are going to cancel.
plus 9.
Plus 9. Very good.
So you can't combine those because that one's to the third.
Now it's the third power. So I'm going to have some issues here.
You
Now,
can distribute them.
there's 2 things that I could do here to make this easier on myself. I'm going to show you both because I like to, do things that make me feel like a nerd. And I want you to understand everything that is at your capability. The first one, anytime we have a binomial to a power,
Pascal's triangle.
we can use Pascal's triangle. That's exactly right. So because I see x plus 1 cubed, I could go to Pascal's triangle and say, hey, because it's cubed, 1, 3, 3, 1, x cubed, x squared, x, nothing, and the ones don't do anything, so couldn't I now say, well, x minus 1 times x cubed plus 3x squared plus 3x plus 1 times x squared plus 9?
Yeah.
Yeah? That wasn't awful, right? But Andrea, you're over there and you really like this conjugate thing, right?
Yeah.
You like it when the middle terms cancel and it makes you feel good about life?
Yeah.
And you noticed, hey, these are conjugates, but one's cubed. Well, guess what? I'm going to use one of them, right?
Yeah.
Times, well, I still have 2 left, correct? And I still have x squared plus 9. So it looks a little bit different, but I'm still getting to the same place. Does that make sense? It's just letting you know there's really no rhyme or reason to what's the best. It's what you're the most comfortable with. Does that make sense? I could have even sat here and foiled that literally 3 times, but I don't want to do that because I like to find all the shortcuts in life. But I still have to finish my problem. Make sense?
Yeah.
So I got to keep multiplying. So back over here, notice how I have 2 things times 2 things. Let's FOIL those 2 things to make them one thing now, right? So x times x squared. Outside plus 9x. Inside. And last. So now I'm going to rewrite that order. But don't I also have this other piece?
The box method.
Now I'm multiplying something big times something big. So the other thing that we've learned holding the box method, I don't even know stone unturned here. We're getting it all. Couldn't I take x cubed minus x squared plus 9x minus 9? Times x cubed plus 3x squared plus 3x plus 1. Was that a whimper I heard back there?
Because it's cold and you want to heat it on.
X cubed times x cubed.
X to the 6.
X cubed times negative x squared.
Negative x to the 5th.
X cubed times 9x.
9x to the 4th. Negative 9x.
3x squared and x to the 3rd.
3x to the 5th. Negative 3x to the 4th.
27x
27x. Negative 18x squared.
Negative.
21. 27.
We'll get it eventually.
There's like 12.
I said 18. Let's make those
3x cubed.
27x squared. Isn't that squared? X cubed. Negative x squared plus 9x minus 9.
Okay.
He said, okay. Now combine all the like terms.
So x to the 6.
Notice how I've set this up in order.
Obvious.
Range.
That cancels that. 27 minus 9 is 18 minus 3 plus 1. Negative 27, positive 27.
Wow, negative x squared.
Negative x squared. Plus 9x.
Plus 18.
No, oh, I forgot.
That is a lot of stuff.
So that's your final answer?
That is my final answer. What makes these problems harder?
All this stuff.
How interesting.
The
they
higher
are.
the degree, the more work you have to do, right? Yeah.
Because like you now have a certain thing you can do, right? I mean, you like started the same way, but there's always some kind of variation.
Yes.
See, that's gonna confuse me so bad.
No, that's why we learned it all. All right, so your homework for today, because these problems take a little bit of time, I'm trying to give you some extra time, and I cut your homework down to only 9 problems.
Only 9, you should have done 5.
You want me to put the other 10 back in there?
No.
Okay.
You only subtracted 1? Wait, how many were there?
At least it's
Said, should I add 10? Oh, I thought, should I put that?
I even took out all the word problems.
Oh, so bad. Is it on HRW?
It is on
You should
HRW.
have done it on Delta.
Kason, you should just do word problems one day.
Well, maybe I will.
Oh, don't do that ever, please.
So tomorrow, we're not at school for the election day.
Yeah.
On Wednesday, when we come back, we're gonna review and practice these, taking these big nasties and putting them down in little things, and taking these little things and writing them into big nasties, you know, going back and forth. And that's it, that's the entire module. On Thursday, we're taking a practice test. On Friday, we're taking the test.
Look at this bread.
Now, this is only like 2 sections, so there's not a whole lot of stuff here. But these 2 things have a whole lot of skills rolled up in them that make your job a whole lot easier.
Is it on HRW?
You've
What's
already
that
asked me
called
that.
again? The something of algebra, the,
Fundamental theorem of algebra?
yeah.
If you have a 6th degree like this one, that's why I had 6 solutions in the beginning. Or because I had 6 solutions, I'm going to come down to
6.
exactly right.